Hi, welcome to an Arduino step-by-step course by Robojax. Let's get started with the multidimensional array. So first we have to define a multidimensional array. What is a multidimensional array? If we have a shape like this and it has a width of 16 and let's say we have a shape something like this, the length is 16 and the width is 9. If you want to define it in a variable of type integer because the value is a number, you have to do it like integer shape. You will put two square parentheses. The first one is the row and the second one is the column, and then this is the original one that you start all the time, and this is number of row or shape because this is one piece, and this is the original opening and closing, and this is one item. For every other item we will have something like that. And if we have two shapes, then we will have something like this. Now we have changed it to 2. So this 16:9 was referring to this, and this refers to 21 and 13 to the shape 2. So this is 0, this is 1, and each have been separated with comma. And if we have third shape, which has 6 by 5, we will change that to 3. This 2 means each element has, this 2 means each item has, this 3 means we have 3 items or 3 rows, and this 2 means 2 columns, or each item has 2 elements in it. So this is a row, 3 rows, and then 2 means 2 columns. So if we have a shape something like this, 3-dimension, which has length, width, and height, in this case we will define integer shapes 1, 3, because this is one shape. This means number of rows or number of items or shape, and then we have to change this first. Instead of 2 we have to make it 3, and now we have 3 values here, 16, 8, and 9, 16, 8, and 9. And then how about if we have 2 items? You see the values are different, shape 1, shape 2. In this case we will just add 1 row and 2 rows, and pay attention here that this has changed now to 2. That refers to 2 rows, and 3 means 3 columns. Each row has 3 columns or 3 items. And pay attention to this comma. Now we are separating a group of curly parentheses with comma, and we don't have a comma here because this is the last one. And now how about if we have 3 shapes? All the values are different here. In this case we change this to 3 and 3 rows or 3 shape or 3 item, but this 3 means each has 3 information or 3 quantities or 3 columns as we call it. So again pay attention to these commas. If there is another item after this we will put a comma, and as you can see the third one is 41, 17, 19. 41, 17, 19 have been placed like this. So you have to be consistent. If this is the longest portion, the length, width, height, so the length, height, width, all of them should be the same so they match. Now how we can read it? These are the values we just did. I just put it like that and then curly parenthesis of blue. So this red is the main array, and each element has blue curly parenthesis separated with comma. And let's say you just want to print, you say shapes 1, 1. This 1, 1 means row 1, column 1. It will print 10 because row 0, row 1. this is 0, this is 1. So 0, 1, 2, row 1, column 1. Each column starts with 0, 1, 2. So this is the row 1, column 1. Now this is 0, 0, row 0, item 0, and it will print 16. And that is referring to this. Now let's see shape 2, 2. As you can see, this is 0, 1, 2, and here we have to start 0, 0, 1, and 2. So it will print 19, and that is our item. If you found this tutorial helpful, please thumb up and also click on the subscribe on the right side in the lower corner. I really appreciate it. Now let's see how we can update this array, these values. The updating of array is exactly the same as a single dimension array or regular array that I've explained in previous lectures. So we put a value and we just put the index address, shapes 1, 0. This means 1 and 0, 0, 1, 1, 0. This value now is being updated. So this shapes 1, 0 refers to 10. And when you put 42, it means 42 should go in this location. Now let's see how we can update array. As I've explained it in previous lectures, with regular array this is exactly the same, except you have to put the proper index for row and column. In this case we have array is called shapes, so you type shapes and inside square bracket row and column. This means row 1, row 0, row 1, and then column 0. That 0 refers to this. So this position, we want to put 42 in here. So 23 will be replaced with 42. Actually, we put 42 in this address, and if you pay attention, this 23 will be replaced with 42. Now this is updated one with 42, and we want to go to position 0, 2, 0, and then 2. We put 15 into this address, and 9 will become 15. Now this is updated array. And now let's update another value. This is the updated array from the previous session that I shown you. And this time we want to put 62 in the position of row 2, column 1. And as you can see, row 2, this means row 0, 1, 2, and then column 1, that is 17. We want to replace it with 62. It becomes now 62. So this was how you can replace or fill up an array or read the values of multidimensional array. And the same way we can have the third column. So that's row, column, and then whatever you call it. In this case, we will have one more value here. And now let's work with the three-dimensional in case if you sometimes face it. We will have, as you can see here, I put them in red is the main array, and this blue is the row, and green is the column, and each column has 4 elements or whatever. So pay attention, or whatever name you call and each column has 4 elements. So pay attention to the comma. Now we have 2 of this because we have 3. So 1 is here and then 2 in each row. And this 2 refers to the 2 column. The 3 means 3 row, and then 4 means 4 items in each column. So 0, 1, 2. So So it has 1, 2, 3, 3 rows, 1 column, and then comma, second column, which has been, each column has green parentheses, and each row is blue. So 4 means we have 4 items. If you found this tutorial helpful, please thumb up and also click on the subscribe on the right side in the lower corner. I really appreciate it. Now let's see how we can read three-dimensional array. Now let's see how we can read three-dimensional array. If we type shape 0, 1, 3, it will refer to this. How this happens is that row 0, row 1, row 2. So this 0 means row 0. We're targeting here. And then we have column 0, column 1. So this is column 0. And then 1 means this. And 3 means element 3. 0, 1, 2, 3. So that's why it prints 7. And let's say if you have 2, 0, 1, again, it will go for 21. See what happens. 2 means row 2 in here. 0 means column 0. So we are looking at this columns. And then 1 means, and then 1 means, and then 1 is because, and 1 means 0, 1. So that is why we will print 21. Now let's see how we can update an array. If we put something like this, shapes 0, 1, 3, this is exactly the same as before. It will go and update this value because 0, and then in terms of column 0, column 1, and element 3, 1, 0, 1, 2, 3. So it will update 7 to 45. Or if we have 2, 0, 1, so row 0, row 1, row 2, and then column 0, which refers to these columns, and then 1 means 0, 1, so it will be 21. And now 21 will be replaced with 31. So this is exactly as assignment. 31 is assigned to this value. If the array, if you define array 3, 4, 0 and leave it empty, this is how you will fill it up. And let's say how we define three-dimensional array empty. So you can do integer shapes, 3, 2, 4. This means 3 rows, 2 columns, and 4 items in each column. So this happens like this: 4 items in 2 columns and 2 columns in 3 rows. Now if we say shapes 2, 0, 1, it means at 2 row. It means at row 2, column 0, item 1, not 0. Item 1 means second item, and the value should be 31. So 31 is assigned to this. Or if we have shapes 1, 1, 3, this means row 1, column 1, and 4th item should be 25. This is an RGB LED. For the reason it's called RGB LED because it has red, green, and blue. 3 LED in one package. And for each we have 1 wire, and then 1 wire is common. And this is the module that is made out of this with resistors that is needed. All the resistors are here, surface mount devices resistor already included. Or you might see it something like this with the resistors. And this is the surface mount device RGB LED with the resistor. The 3 resistors are included with the module, so you just connect it and makes wiring very easy. And this is the symbol for RGB LED. I made it as color. You might not see it as color, but 3 LEDs are in one package. And they are offered in common cathode, which the cathodes are connected together, or common anode, which the anode are connected together. You just need to supply in common anode negative voltage or lower potential than anode to the cathode to turn this on. RGB LEDs, either surface mount, SMD, surface mount device, or this type of 5mm or maybe larger sizes are available. For all of this, you need to calculate and put resistor to turn it on, like the regular LED that I've shown you in previous lecture. And here, if the LEDs are offered in common anode, which common is here, so you cannot put your resistor individually on each. You have to put individual resistor for each. You cannot put one resistor for all. If you put one resistor for all, if you turn on one of them, the intensity of light will be different or higher. If you turn three of them, there will be more voltage drop on one resistor, and you will always get inconsistent color. So you have to put individual resistor on each. If you have common cathode, then you put your resistor on anodes. And if you have common anode, you put the resistors on cathode, and this side will be connected to negative. RGB LEDs need to be forward biased like regular LEDs, meaning that a voltage should appear across anode and cathode in order for the LED to turn on. The voltage that you need to turn an LED on is called forward bias voltage or forward voltage simply. Let's have a look at this RGB LED on a spark fan. They are selling it, and look at the description. For the forward voltage that it needs to get fully illuminated, for R it needs 2 volts, for green 3.2, and for B, for blue, 3.2. And this is very inconvenient. You have to calculate and put different resistors based on this voltage, as I've explained in previous lectures. Let's have a look at the data sheet. This is one data sheet. There are many. One of the company, Yangsun. And here they've mentioned amount of current, 20 milliampere. That's good for red, green, blue. The amount of current is the same. And here is a forward voltage for R, G, and B, 2, 3.2, 3.2. Because this is common cathode, the drawing have been provided. Pin 1, 2, 3, and 4 are the R, red. So this is the R, that's the G, that's the B. And the long pin number 2 is a common. And here is a data sheet for the common anode. As you can see, anode is common. Pin number 2 is the longest pin. That's the common. Pin 1, 3, and 4 are R, G, and B. As you can see, for red, green, and blue, the voltage range is not consistent. For red is 1.8 to 2.2 volts. For green, 3 to 3.2 volts. And for blue, 3.2 to 3.4. So they are all not in the same range. If you see from the top, there is a small cut, and that is referring to this and the data sheet. So it means you look at it from the top, and here are the pins 1, 2, 3. These are all anode, and 4, 5, 6 are the cathode. 4, 5, 6 on this. That's why this is the cathode. Why these are the cathode. They have been connected to the ground. This is common cathode. And these pins are separate. Here they have been connected through the resistor. And for this module, as you can see, I've taken the picture here, and the 3 resistors that are here, this is 102, this is 1000 ohm, this 2 means 2 zeros, and this is 181, 1 means 10, this is 180 ohm, and this is 180 ohm. They included the resistors for you. It is 5 millimeter, and the pins are 1, 2, 3, 4, 5, 6. 1 and 2 is for the R, 3 and 4 is for the B, and 5 and 6 is for the G. They didn't put it RGB or BG. In the surface mount device, there is no common cathode or common anode because you can configure it whichever way you want. When your LEDs are common cathode, you just connect this to the ground, and from that side you supply the voltage. And when you want, for example, to turn on in red, this will be turned on, and you keep the other 0, 0, so this will be turned on. But if you want to do the same thing with this, you will have problem because the negative is on this side and you have to control from here. In order to turn on the red LED, you have to keep this 0 and you have to keep this and this high, which means this must be 5 volts because the other side is 5 and 5. This will be kept off. So these two pins must be high and this must be low in order to turn this on. So this is the reverse of that. Here is how you calculate the resistor. For example, if you connect 5 volts, in this case Arduino or a battery, to an LED, and let's say we found these information from the manufacturer, and by the way, these are the most common values. The voltage of the LED is, let's say, 2 volts, and the current that it needs to have enough light is 10 milliampere or 0.01 ampere. Now, because this is 5 volts and we have the voltage across LED 2 volts, then 5 minus 2, 3 volts must be across this resistor, divided across this resistor. So if this is 3 volts, then R will be calculated by the Ohm's law, V divided by I. V is the voltage, I is the current. So V is 3 volts, I is 0.01, and we will get 300 ohm resistor. If you go below this, then the voltage across this will be smaller and the higher voltage will be here, and as a result we will have higher current, and this will damage the LED. But if you set this larger resistor, there will be larger voltage drop and smaller voltage for this. Instead of 2, it will be, let's say, 1.9, 1.8, or even less and less, and that will cause the brightness of this to be decreased. And if you go very high, let's say 3 or 5 kilo ohms, slowly you will see that you will not be able to see it. It will be very dim. Something up to 1 kilo ohm will work fine and it's visible. So how do you know which pin is for R, which pin is for G, which pin is for B, RGB? As I said, the LEDs could be common anode or common cathode, and the longest one is always the common. So how do you know which pin is for R, which pin is for G, which pin is for B, RGB? As I said, the LEDs could be common anode or common cathode, and the longest one is always the common. And then when you get the common, it's, as you can see, this is to the right. If this is to the right, because 2 on the other side, and this is leaning towards the right, from this side that is red, green, blue. If you hold it like this, longest, now the longer pin is to the left. Connect common to the resistor pin. So insert it in your breadboard such that the long pin is connected with the resistor pin. Now, because this is common, I will use this as a common, and then now I have connected 2 wires to my Arduino, one to 5 volts and the other one is to the ground, and I put red for 5 volts, and let's connect it here and see how this turns on. That is the reflection of my light. First I connected the black to this pin, which is to the common, and I'm going to put this red into different pins, in here, in here, and in here. So it did not turn on. Now immediately I know that I have to switch it, connect the red or positive to the common via that resistor, and then connect this to the different pins and see. This is now red, it turned on. If I connect it to the, not to the common because there is a resistor, that's the same pin. If we connect it to the common, nothing happens. This is green and this is blue. Because of the camera and the light, you don't see it properly blue, but here with my eyes it's a perfect blue. So we have RGB when the longer pin is to the right. If you found this tutorial helpful, please thumb up and also click on the subscribe on the right side in the lower corner. I really appreciate it. Let me now explain the code and also demonstrate it. We are defining pin 11, pin 10 and pin 9 respectively for green, red and blue pins. And then color time 2000, this is just when I demonstrate the different colors, this will be the delay time. I've also defined 9 colors here, each has 3 values, RGB, red, green and blue. This is two-dimensional array, and we have 9 elements. Each element has 3 values. For example, for white, RG and B is maximum. For red, only red is on and the other are off. 255 mean maximum. Red, green and then blue. For yellow, red and green is high, maximum, and then blue is 0. For aqua, red is 0. These two are maximum, and so forth. So we are creating these colors. This color picker, this is from w3schools.com. Here you will get the RG and B value here. If I put the slider maximum, that means green is max, red is max, and blue is max. That's why you are getting this color. And if you turn the red 0, you get this aqua color, and if you make that green also disappear 0, you will have only blue. The reason is that the blue is maximum. And then if you have 255 red and blue but no green, green is 0, 255 is the maximum, you get this purple color. Or if you have 255 and then blue is 0, you get yellow. So you can move the slider and change different value or even type to get different color here. And in this array I have stored the color name. It's called color name, and with 8 values. For each value I have here a text, so this can be printed for us. And inside the setup we are defining pin red, green and blue, which are pin 11, 10 and 9 as output. And after setting the pin as an output, we are using digital write to set the same pin low to turn it off, and the same thing for green and for blue. This is a loop. If you want to turn on green, for example, this code, it says analog write red 255. This means send the maximum duty cycle for red, so this is the maximum intensity, and then wait for 2 seconds and then send 0, which means turn the red off. After this we are doing analog write green 255. Now this time, because red is off, now we are turning the green on, and then we wait for 2 seconds. After that we are turning the green off and then blue on, which is 255, that's the maximum blue, and then turn it off, wait for 2 seconds and turn it off, and the loop continues like that. I have updated the code by adding this serial.println and then color name 1. This one refers to red. This is 0, 1, 2. From this color we are picking up the text to print it for us. It will also print the color name for us. And here is now the demonstration. As you see, it shows red here, and we see the same color being printed: red, green and then blue. Let's see what we have here. So we have yellow if we have these 2 colors. Now I've changed the code so we can get yellow, and the yellow was red is 255, green is 255, and blue, which is at the beginning, is 0. We just print this text, wait for 2 seconds and then turn red and green. The 2 that we turned on here, we are turning it off by setting 0. You see, yellow and green, and then it should go to blue, and again back at yellow, it goes to yellow, green and blue. This can happen with this larger module that we have. That's blue, that's yellow, and then we have green and then blue. Yellow, green. I've written this function RGB LED, which needs 3 parameters. The first one is for red, green, and then blue. For example, if you want to turn the red LED on, just send 255, which is maximum intensity for red, and for green and blue send 0. So this will be just red, and wait for 2 seconds, and then turn off everything. So by sending 0, 0, 0, the LEDs will be turned off, and then this will sense green because green is 255, red and blue is 0, and then wait for 2 seconds, turn off, and this is for blue because only the blue has a value. When it arrives here, the first value becomes R, small r, the second one becomes G, and the second one becomes B of type integer variable, and then here using analog write we set that we pick the pin and put the value for R, and then the pin for green, which is pin 10 for green, and then for blue pin 9. So this function does it automatically for all. So you just type one line and it will do it for you. And now here is the demonstration: red, green, and then blue. Each color, again red, green, blue. This will run. I want to do something else. 255 0, this will be different color, and let's go here. 255 red is 0, green and blue is 255, and here let's put 255 0 and 255. So yellow, this is aqua, and then pink, and this is yellow, this is aqua, and then pink. Inside the loop I've put my own loop, the for loop, which starts from here to here, and we use the same function that I've shown you, but this time we are picking up the color name from the array. This says, this because the variable is J, we say color J. J becomes 0, 1, 2, 3, and it goes here and picks up one of the it picks up one of the 8 colors that we have here, the values, and then this 0 means pick up the first value. So this will be red, this will be green, and this will be blue. And 0, 1, 2 means the first element, second element, and third element of this array, first, second, and third. And also we, in the same time, we print the color name from the array, and we wait for the color time that I have explained at the beginning. Here now it prints the name with the color, as you can see: green, blue, yellow, aqua, pink, orange, and then it goes back, white, and so forth. Color variation is due to the lighting and the camera, and also because the camera is very close. Now let me show you with this module. Here is the wiring for RGB LED common anode. Because this is common anode, the middle pin have been connected to the positive. From the right, this is red, green, the third one, and blue is the last one. Red have been connected via 1 kilo ohm resistor to pin 11, and then the third pin is green, have been connected through 1 kilo ohm resistor to pin 10, and the last pin from the right is the blue, have been connected via 1 kilo ohm resistor to pin 9. Now I've updated the code. I will provide you this code separately. This is for common anode or common cathode. This works for both. And type 0 for common cathode and 1 for common anode. Now I have put here anode. All the code is the same. the values are still for the other LED, but here I've done here a simple arithmetic. It says if type is equal 1, which we defined it above, whatever value you, if you turn on red with 255 and it was common cathode, then you send 255. But for common anode, look what happened. 255 minus 255, it will be 0. So this time we have to send the opposite. And the same for green, for red. And let's say for blue, you are sending 0. Blue is supposed to be turned off. Now 255 minus B, which is 0, would be 255. So we will send 255. So that will turn off the LED. So this arithmetic will convert the function from common cathode to common anode. Now let's see it. Here is the code that I have. And as you can see, yellow, aqua, pink, orange, and then we have the loop continues, it becomes white, red. You might claim that the colors, the mix-up colors are not the same as claimed. The reason for that is because the camera is very close. If you get away or if you stay in a distance from the LED, you will see proper color. Please make sure to subscribe by clicking at the subscribe button in here. Thank you. Thank you for watching the tutorial from Robojax. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, please post it at the comment section below. I try to answer and reply. And don't forget to subscribe so you get updates of my upcoming videos.